Welcome to 4.8.1, Applications of Trig Functions, Part 2. Our standard and essential question are the same, so how can we find an angle if we know the value of a trig function? This time we're going to be looking at word problems. So, looking at this word problem, it says, from a point on level ground 80 feet from the base of the Eiffel Tower, the angle of elevation is 85.4 degrees. Approximate the height of the Eiffel Tower to the nearest foot. So, first thing that I would do is draw a picture to help you. So you know from a point on the ground, 80 feet from the base of the Eiffel Tower. So you have a straight line there. You have an angle of elevation of 85.4. So you can draw a right triangle based on that. Yours can just be a triangle, you don't need to draw the Eiffel Tower. But we want to approximate the height of the Eiffel Tower, so you want to approximate A to the nearest foot. So we have our adjacent and we're looking for the opposite. So I would use tangent of 85.4. You want the opposite, so A, over your adjacent, which is 80. So you have 80 times the tangent, 85.4. And that's going to give you your A. So when you solve it and it says to the nearest foot, that's going to give you 994 feet. So the Eiffel Tower is approximately 994 feet. Now we're going to look at a different one. It says a guy wire is 13.8 yards long and attached from the ground to a pole 6.7 yards above the ground. Find the angle to the nearest tenth of a degree that makes the wire on the ground. So here's where it's attached to the ground. And here's my pole. So you know your guy wire is 13.8 yards long, and it's attached to the pole at 6.7 yards above your ground. So you have your hypotenuse, because this is your 90 degrees, and you have your opposite. You are looking for this. So you have your opposite, and you have your hypotenuse. So let's see what we can use. So since you have hypotenuse and opposite, you do want to use sine. So you have sine theta equals 6.7 over 13.8. This looks familiar, or it should. You need to be able to find theta. So you want to use your inverse functions. So this means you have theta equals sine inverse of 6.7 over 13.8. So on your calculator you want to plug in sine inverse, which I believe is second and then sine, of 6.7 over 13.8, and this should give you about 29.0, so about 29 degrees. It does say to the nearest tenth of a degree, that's why I added in my 0.0. So when you're finding theta, or you're finding your angle, you will want to use your inverse. Sometimes people find drawing the picture to be the hardest point, so I'll help you draw this one and then you guys will solve it on your own. So a building 190 feet tall casts a 30-foot shadow. If a person standing at the end of the shadow looks up at the top of the building, what is the angle of the person's eyes? So pretend the person's eyes are about 4 feet from the ground. So here's my building. There's 190 degrees, or 190 feet, sorry. And it casts this 30-foot shadow. And here's my person. Now this person's about 4 feet from the ground. And you want to know the the angle of elevation. So this is 4 feet right here. You want to think, what is this part of your building? Because this is the part you're really going to use. So if it's 190 degrees total, and they're 4 feet above the ground, your building, when you use this, is going to be 186 feet. So you want to pause the video and solve this one on your own. So you're going to do tangent theta equals 186 over 30. So that means you're going to have theta equals tangent inverse of 186 over 30, which is about 80.84. It does say to the nearest 100 of a degree. So this is your answer. So complete the questions below, and then complete your homework assignment. Next class we're going to work on more trig application.